A very good morning, class 10. From today we are going to start a question, okay, which is a combination of cones and cylinder. This is exercise 20G, page number 316. Question number 3. A right circular cylinder having diameter 12 centimeter and height 15 centimeter is full of ice cream. So one cylinder is there whose diameter is 12 centimeter and height is 15 centimeter, and that cylinder contains ice cream. Okay, the ice cream is to be filled in identical cones of height 12 centimeter. So that ice cream, okay, from the cylinder you have to fill in that cone. The ice cream should be filled in the cones whose height is 12 centimeter and diameter is 6 centimeter. You have to remove this part because hemisphere is not in syllabus. So till here only, the question will be till here. You have to find the number of cones required. So how many cones are required? So this is cylinder whose height is 15 centimeter, diameter 12 means radius is 6 centimeter, and you have to fill this cone with ice, okay, and the height of this cone is 12 centimeter and the radius is 3 centimeter. Diameter is given 6, so radius is 3 centimeter. So for that you have to find the volume of cylinder as well as the volume of cone, okay. Then you have to find the number of cones, right? What you have to do, you have to divide the volume of the cylinder by volume of cone to get the number of cones. So right circular cylinder and cone. So radius is 6 centimeter, here radius is 3 centimeter. Height is 15 centimeter, here height is 12 centimeter. You have to find the volume of a cylinder, pi r square h. Okay, do not put the value of pi because this pi will cancel with this pi afterwards. So r is 6, h is 15. Here r is 3 and h is 12. So this 3 and 3 can be cancelled. 12 into 3, okay, pi into 3 into 12 centimeter cube. You can keep like this. Now you have to find the number of cones required. So to find the number of cones, okay, the volume of cone will be down. Volume of a cylinder by volume of a cone. So put the value, pi and pi cancel, 3 2s are 6, 2 6 are 12, 6 cancel. So 15 cones are required. Now next is question number 15. Okay, we will do only question of cylinder and cone. So we will do directly question number 15. This is ICC 2001 question. An exhibition tent is in the form of a cylinder surmounted by a cone. So this is the shape. Okay, down it is in the shape of cylinder and up it is cone. And the height of the tent above the ground is 85 meters. So height of the cone is 85 meter. Tent is 85 meter. And height of the cylindrical part is 50. Means this is 50. If this is 50, then this will be 85 minus 50, which is 35 meter. That means the height of the cone is 35 meter. Height of the cylinder is 50 meter. Now, if the diameter of the base is 168 meters, so diameter of the base is 168 means radius is 84. The radius of cylinder is 84 and the radius of cone is also 84. So here what you have to find the quantity of canvas. Canvas is the cloth required to make a tent, okay. It is green in color, okay. Most of the clothes, it is green in color. So required to make the tent. So you have to find how much canvas is required, okay. Here one more condition is given, allow 20% extra for folds and for stitching. So we need extra clothes also, no, for stitching and folding, okay. We need more clothes, okay. So give your answer to the nearest meter square. So for that, okay, we will cover the tent from only outside. We don't cover the base, okay. So you have to find the lateral surface area of the cone and the lateral surface area of the cylinder. Then you have to add, okay. That will give you the quantity of canvas required. So cylindrical part, radius is 168 by 2. 84, height is 50. Now lateral surface area is 2 pi RH. 2 into pi into 84 into 50. So I kept pi like this, okay. You can put value also, but I kept like this, okay. 8400 pi meter square. Now we will find the lateral surface area of cone. So for conical part, radius is 84 meter, height is 35 meter. So lateral surface area is pi RL, but we don't know the value of L. So we will find here, okay. L square is equals to h square plus r square. H is 35, r is 84. So 35 square is 1225 and 84 square is 7056. On addition you will get 8281. So square root of 8281 is 91. So L is 91. So put the value, then pi you keep like this. Then canvas required to make the tent is, you have to add the lateral surface area of cylinder and cone. Then you can put the value of pi. Okay. Now we can cancel. 7 1s are 7, 7 2s are 14. Then 2 will be here, 7 2s are 14. Then 6 will be here, 7 8s are 50, 7 9s are 63, 7 2s are 14. Now 2292 into 22 is 50,424 meters square. Only to cover this is 50,424, but you have to keep 20% extra cloth. Okay, you have to bring 20% extra cloth. So 20% of this one. So total quantity of canvas required is this one plus 20% of this cloth. So after solving this, you'll get 60,509. Because answer is asked in nearest meter. So this 8, okay, it is more than 5. So 1 will be added here. So it is 60,509 meters square. Question number 20 is, a conical tent is to accommodate 77 persons. Means 77 person can stay inside the tent. Okay, a space inside the tent is for 77 persons. So each person must have 16 meter cube of air to breathe. That means volume, the space occupied by one person is 16 meter cube. Okay, and 77 person can stay. Okay, can sit inside that tent. So the volume of tent we can find, the space inside the tent is 77 into 16, because for one person volume is 16, the space required is 16. So for 77 person it is 77 into 16. That will give you the volume of that conical tent. Okay, and the radius of the tent is 7 meter. Here you have to find the curved surface area. Okay, height and curved surface area. So height, or it is radius, okay, not height. Height is 7 meter and volume required for one person is 16 meter cube, and volume required for 77 person is 16 into 77, which is 1232 meter cube. Now volume is given. No, this is the volume, and formula is 1/3 of pi r square h. For cone it is formula. Okay. Now r is 7 square into h. Then we can cancel this 7. So 22 into 7, 154 by 3 into h. We need the value of h. So this fraction will become reciprocal on the right hand side. Then we can cancel here with 7. 7 2s are 14, 7 2s are 14, 7 1s are 7. 7 here, 5 7 7s are 49. Then comes here 4 here, 7 6 are 42. Now again we can cancel 2 11s are, 2 8s are, 2 8s are. Now 11 1s are 11, 11 8s are 88. So 8 into 3, 24 meter. Height of the tent is 24 meter. Now we have to find the lateral surface area. So curved surface area formula is pi RL. We don't know the value of L, so we will find the L. L square is h square plus r square. H is 24, r is 7. So 576 plus 49 is 625, and the square root of 625 is 25. So the value of L is 25. 7 cancel. Answer is 550 meters square. Now this is your ICSE 2018 question. Okay, the circumference of the base of a cylindrical vessel is 132 centimeter. This is your cylindrical vessel whose circumference of the base is given 132 centimeter and its height is given 25 centimeter. You have to find the radius of the cylinder and volume of the cylinder. So height is given 25, radius is question mark, circumference is given 132, formula is 2 pi r is equal to 132. The value of pi is 22 by 7 into r. Now 2 into 22 is 44. 44 by 7 into r is equal to 132. Now this fraction you have to keep on the right hand side. Now we will cancel. 4 3s are 12, 4 1s are 4, 4 1s are 4, 4 3s are 12, 4 3s are 12, 11 1s are 11, 11 3s are 33. So 3 into 7, 21. So we got the radius. Now we have to find the volume. Formula is pi r square h. R is 21, h is 25. Now 7 3s are 21. So on multiplying these four numbers, you will get 34,650 centimeter cube. This is the volume of cylinder. This is also 2018 question, but this part is removed from the syllabus. Okay, so we will solve only for this diagram. Okay, we will remove this hemisphere, then we will solve this question. So I have removed that hemisphere from the question also. The adjoining figure represents a solid consisting of a right circular cylinder with cone at the one end. Okay, I have removed the hemisphere. Their common radius is 7 cm. That means the radius for cylinder and cone is 7 cm, and the height of the cylinder and cone both 4 cm. Height of the cone is 4, height of the cylinder is also 4. You have to find the volume of the solid. So to find the volume of the solid, you have to find the volume of cone and volume of cylinder. So for cone we will do first height 4, radius 7. So volume of a cone is 1/3 of pi r square h. Just put the value, then 7 cancel, multiply the numerators, it will be 616 by 3. And on dividing, you'll get 205.33 centimeter cube. This is the volume of the cone. Now we will find the volume of cylinder. Height and radius formula is pi r square h. Now 7 cancel, 22 into 7 into 4, 616 centimeter cube. So volume of the solid is volume of cone plus volume of cylinder. Volume of cone is 205.33 and volume of cylinder is 616. So on adding these two numbers, you'll get 821.33 centimeter cube. This is the volume of solid. Now question number, this is ICC 2020 question. Okay. From a solid wooden cylinder of height 28 cm and diameter 6 cm. This is your cylinder. Okay, cylinder whose diameter is 6, means radius is 3, height is 28. Now from this cylinder, 2 conical cavities are hollowed out. That means from this cylinder, 2 cones are removed. Okay, you have to scoop out these 2 cones from the cylinder, and the diameter of the cone is 6 cm, means radius is 3 and height is 10.5. This height, both are same, okay, identical cones. You have to find the volume of the remaining solid, means after removing the 2 cones, what will be the volume of the remaining solid. For that, you have to find the volume of cylinder. From that volume of cylinder, you have to remove the cones. Okay, you have to subtract the volume of 2 cones. So cylinder, you find the volume of a cylinder first, then you have to find the volume of cones. Okay, directly we'll find the volume of 2 cones. 2 into 1/3 of pi r square h. Then you simplify it. Okay, 3 and 3 can be cancelled out. 7 1s are 7, 7 1s are 7, 7 5s are 35, 5 3s are 15, 5 2s are 10, 2 cancel. Now multiply this, you'll get 198 centimeter cube. So the volume of 2 cones is 198. Okay, so you have to remove this. So volume of remaining solid when 2 cones are removed from the cylinder is volume of cylinder minus volume of 2 cone. Volume of cylinder we got 792 and volume of 2 cones 198. So answer is 594 centimeter cube.